How many significant figures does this number has? We want to know the number of meaningful numbers that we have in this length. By the way, 25.0 is a unit of length. As you can see, its a unit is meter, so it belongs to the physical quantity length or distance. They are the same. This is a physical quantity that belongs to meter, or I mean length, which is the same as 25.08 meter. How many significant digits that this number has, or figures, significant figures or digits? Now, just to make this clear, let me show you a table. There are rules that helps us determine whether a given zero is significant or non-significant. But before that, what is the meaning of significant figure? What's a significant figure? Significant figures are digits in a measurement that are known with certainty plus the first digit that is uncertain. Or significant figures are figures in a measurement which are meaningful. Or significant figures help us keep track of imprecision. Now let's see the rules for determine whether the zero are significant figure or not. The first rule is zeros between other non-zero digits are significant. Like here 50.3. This zero is sandwiched between two numbers. In this case, this zero is significant. In this particular example, we have three significant figures or digits. 1, 2, 3. This has three significant figures or digits. Let's take the second example. This second 3.0025 seconds. Now these zeros are sandwiched, or they are found between two numbers. They are found between two numbers. So in this case, they are counted. They are significant. So we have 1, 2, 3, 4, 5. We have 5 significant figures or significant digits. The second one is zeros in front of non-zero digits are not significant. For example, here, let's see, 0.892. It could, like, call it a kilogram or whatever you want. In this case, this zero is in front of non-zero number. Like, it's in front of one non-zero number. In this case, this zero is not significant. We don't count it. So in this case, how many significant do we have? 1, 2, 3. We have 3 significant figures. Let me give another example. If you have 0.0008, in this case, we don't have any number in front of these zeros. So in this case, all these zeros are not significant. These are not significant. We have only one significant figure. In this case, we have only one significant figure or one significant digit. The third rule is any zero that are found at the end of a number or to the right of a decimal are significant. For example, in this case, look, this is a decimal point, and after this decimal point we have 2 zeros. In this case, these 2 zeros are significant. These are significant. Now in this particular example, we have 4 significant digits. 1, 2, 3, 4. In this case, we have 4 significant figures. Let's say the second case. Let's see the second case. After decimal, this decimal, we have 6 zeros. We can count them. 1, 2, 3, 4, 5, 6. Now, these 6 zeros are significant. We count them. So we have 6 zeros and 1, 2. All together, we have 7 significant figures or significant digits. The last rule is numbers which are written in this form, we cannot say that they have 1 or 2 or 3. They can have 1 or 2 or 3. We cannot exactly tell the number of significant figures they have, because let me show you. For example, 1000 can be written as, I can write this as 1.000 multiplied by 10 to the power of 3. In this case, this has how many significant digits? 1, 2, 3, 4. It has 4 significant figures. I can also write this as 1.00 multiplied by 10 to the power of 3. I can. So in this case, we have how many significant figures? In this case, we have only 3 significant figures. So numbers which are written in this way do not have fixed number of significant figures. They change. The number of significant figures varies or changes, because we can write them as a power of 10 in a different ways. That's why we cannot exactly tell the number of significant figures they have. So numbers written in this way have no fixed number of significant figures. Now let's come back to our question. Let's get back to our question. This case, as I explained earlier, 25.08 meter. This case, this 0 is sandwiched, or it's found between two. We found it before between two numbers. So according to our rule, this 0 is significant. We count it. It is significant. We count it. So this number has 1, 2, 3, 4. It has 4 significant digits. This number has 4 significant figures. Then the answer will be B.